So this is what you did over the weekend, or what you should have done over the weekend. And the answers are available to you. Obviously, it says if you just click on show answers, you get them all. The idea there was so that you could get some feedback before you even get here, so you're not completely lost over the weekend and not being able to do anything for those 5 days. So we'll go through like just a quick, like 4-1 was all the transformations. So remember, there's a Quizlet for all of those too that should help you. You're just identifying the type of transformation on your test. So if I gave you the x and then the xy that's adjusted, could you identify what the type of transformation is? That's what you want to be able to do for that section. And then section 4.2 was identifying your triangles based on the angle measurements and the sides. So remember, acute, equilateral, acute, equiangular, right, and obtuse would be by its angles, and then isosceles, scalene, and equilateral would be by the sides. So it's like 4 and 5, and then 6, 7, and 8. And then number 9, you had to use what you know about an equilateral triangle or an isosceles triangle to figure out value for x. So like something for number 9, I would have just picked the 2 congruent sides, set them equal to each other, and find your value for x. And then 3 is where you started your angle measurement. So this is where we learned that the 2 acute angles of a right triangle are complementary. We learned about the exterior angle being equal to the sum of the 2 remote interiors. We learned that all the angles inside a triangle that is equiangular would be 60 degrees. All that stuff was in 4.3. So you want me to go over a specific one or just pick one? Okay, so like number 12, let's just say, right? Number 12, well, number 10 and 11, those are one of the acute angles of a right triangle, which means you could just subtract those numbers from 90 to get the missing angle. And then number 12 is an example where you have an exterior angle. Okay, so 124 is the sum of the remote non-adjacent angles that are inside that triangle. So for this one, I would say that 10x minus 5 plus 8x plus 3 would have to equal 124. So this is 18x minus 2 equals 124. 18x would equal 126, and then divide both sides by 18. So I can actually simplify that, make it smaller numbers. 3 goes into both of them, 42 over 6, and then that's 7. And then if it wanted a specific angle, like it does this time, it says to find the measure of angle A, I just have to take that 7 and plug it back in. So 10 times 7 minus 5, 70 minus 5, which is 65. I would be very, very careful with your instructions on your test. Sometimes it asks you for x. Sometimes it asks you for the measure of an angle. You've got to make sure that you read the difference and know to plug it back in if you need to. You don't want to lose credit just because you don't read instructions. So then 13, this is that third angles theorem that says if two pairs of angles are congruent, so they're both right angles, and these are both marked as congruent, then the third angles would also be congruent. So 2x squared minus 25 would equal x squared. And then you can either add the 25 to the right, subtract the x squared from the left. Either way, I get x squared equals 25, so x would actually equal plus or minus 5, because when I square it 25, it's positive and negative. So there's no squares on your test, but as long as you can figure out how to, like set them equal to each other. If I had 3 angles, add them to 180 degrees. If you had an equilateral triangle or equiangular triangle, set each angle to 60, something like that. Any other questions up to 4.3? All right, so then 4.4 was identifying the corresponding parts. Could you match them? Okay, GH were the first 2 letters, which means it's JK. JL is the first and the last, which would mean it was equal to GI. And then angle K is in the middle, which means it's equal to angle H. For number 17 and 18, it says LMN is congruent to PQN. So that tells you that L is congruent to P, Q is congruent to M, and then these are congruent and they're 90 degrees. So if I knew that, then I would know that these 2 are equal. 8x plus 12 would equal 10x minus 3. Subtract the 8x, add the 3. And x is 15 over 2 or 7.5 or 7.5. And then if it asks for angle LMN, I would have to take that 7.5, plug it back into either one of these, really, because they're both the same. And then subtract it from 90 to get the angle on the outside. So I'm going to plug it in here because it's easier. 10 times 7.5 minus 3. 75 minus 3, and that's 72, which means this is 72 and this is 72. And then because this is 90, 72 plus m has to equal 90, so 90 minus 72 would be 18 degrees, which is what angle M would equal, and angle Q. 7.5 or 7.5.
Wait, so, okay.
So that was for 4, right? Like if triangles are congruent, then all the corresponding parts are congruent, that kind of thing. And then 4, 6 is where we started our acronyms, right? Side, 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 angle, side, angle, side, angle, side, angle, side, and hypotenuse, leg. 5 acronyms to proving triangles are congruent. So for 19, what do you see there? Are they congruent?
Yes.
Why?
Because both sides are given and they share a reflective side.
Good. QR would be equal to QR. That's reflexive. How about 20?
Same thing.
Same thing. 2 pairs of sides already marked as congruent, and UW is congruent to UW because it's reflexive. Numbers 21 and 22, like your test would say what value of x would make these congruent based on side, side, side. So you'd have to actually find the values of x. So for 21, you'd have to show, and again, order of letters is important here. X, Y matches AB. So 5x minus 8 would have to equal 12. 5x would equal 20, and x would equal 4. Or second and third, YZ would have to equal BC. 15 would equal 6x minus 9. So 24 would equal 6x, and x would equal 4. Or the last ones, x, z, and 2x minus 3. 5 equals 2x minus 3. 2x would equal 8, and x would equal 4. So no matter which pair you set up, if this was side, 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 all 3 pairs would have all had to give you the same x. And then 22, you've got your right angle marked here. You've had a reflexive side marked here. And then this side, this would have to be 90. Because those angles would have to be the same. And these would have to equal each other. Either way, you get y is 8. So test-wise, it would say something like what value would y have to be in order to prove those are congruent by side, 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 or side, angle, side. And you would know it from what you just got. And then 4, 6. Okay, 4, 6 was the other acronyms, right? So now we got into angle, side, angle, side, angle, side, and hypotenuse, leg. No, angle, angle, side, and hypotenuse, leg was 4, 6. So if you're looking at 23, it said if you determine if you can use angle, to prove that the triangles are congruent. Was there information to prove for 23?
No.
No. How many pairs of angles you got marked? 1. And how many sides you got marked?
None.
None, but
But you have a reflective.
you do have a reflexive side. So I've got 1A and 1S.
Yeah, so
But that's it.
You need more info.
Good. If I asked you to prove that using angle, side, angle, what other piece of information would you need?
The other angle.
This angle here, right? So angle ACB would have to be marked as congruent to ACD. All right, 24. How about now?
Yeah.
Yes, reflexive side makes that angle, side, angle. All right, and then 25 says determine if you can use hypotenuse, leg to prove that the triangles are congruent.
No, you need the hypotenuse.
Good, you need the hypotenuse, and it didn't say anything about the side lengths. So for this one, all you knew was that the angles were congruent, right? And then 26,
Yes.
Yes, this time there was enough information. You've got the right angle, you've got the hypotenuses, and then the reflexive side would also be marked as congruent, or would also be congruent. Okay, and then the proof. So the proof on your test, there are 2 of them, but they are the, here's the statements, give me the reasons kind of a thing. So as long as you can fill in the reasons, you should be okay. So this one says that MN is parallel to LP, and angle MN is congruent to angle L. That's given. And those are already marked. So what else can you tell me about this diagram that's not already marked? Look for the obvious.
MP equals MP.
Good. The reflexive side, MP equals MP. So the question really is, if I wrote MP equals MP, could you identify that as reflexive? Hopefully all of you would say yes, and if that's the case, then you're okay. And then, so I've got 1 pair of sides, 1 pair of angles. I need some other piece of information, and they gave me that the lines are parallel. So if MN is parallel to LP, why would they tell you that they're parallel? What do we know about angles formed by parallel lines? What kind of angles? What kind of angles formed by 2 parallel lines and a transversal would be congruent? Corresponding would be congruent. What else? Alternate interior, alternate exterior. So I don't have any exterior because there's nothing outside. Okay, if these are my parallel lines and this is my transversal, then I don't have corresponding because those would take me outside as well. What I do have is alternate interior. So angle NMP is congruent to angle LPM because the alternate interior angles theorem. Now do I have enough information to prove that those triangles are congruent?
Yes.
Yep. I could say triangle PMN is congruent to triangle. Which way did I go? I went PMN, so I have to go M. And that is, we said this is an angle. This is the second pair of angles, and then the side. So angle, angle, side. And then the last thing I wanted to get to was that ML is congruent to PN. So if my triangles are congruent and I go a step further to say that parts of it's congruent, what's that called? What tells you that parts of congruent triangles are congruent? CPCTC. Yep. So once I prove that triangles are congruent, which is what I did here, right? Whoops. Once you get that they're congruent, then I can say that anything that's not already marked, all the corresponding parts are also congruent. Which means I could have said, like for that statement, I could have said that these angles are congruent, because once the triangles are congruent, all the corresponding parts are congruent. I could have said that these sides were congruent. I could have said that these sides are congruent. So if you're working to prove that they're congruent, and then you take it to the next step, which is not only the triangles are congruent, but all the individual parts of those triangles are congruent, that's CPCTC. All right, so this one, and I think it gets a little bit harder when you've got 3 triangles built into one. You just got to take it piece by piece. So number 1, obviously, is you're given that angle 1 equals angle 6, angle 4 equals angle 6, angle 1 equals angle 3, and AB equals AE. All that information is given to you. So it could be in one step, or it could be broken down into parts.
Yeah, how do you know that the givens are broken down into many parts and they're just used?
The statements will actually be given to you. So your job's just going to be able to do the reasons. But either, if you were doing a blank proof, it would not matter. You could choose how you wanted to do that. So all that information is marked, right? 1 is to 6, 4 is to 6, and 1 is to 3. Those are all marked. And then AB equals AE. Those are the outer 2 sides. Those are all marked. So this time, instead of saying that 2 things are congruent, I'm saying that ACD is an isosceles triangle. What makes a triangle isosceles?
They have at least
Two sides the same. So what I have to do is figure out how to get to where these two sides are the same. If those two are the same, would that be an isosceles triangle? So work your way backwards. How could I make those sides the same? Think about how I would use the outside triangles. Not reflexive, but they would be a pair that if the outside triangles are congruent, would those two be congruent? Yeah. What would be your reason there? If I said the two, if I worked to prove that those two white triangles right now are congruent, so then I said AC is congruent to AD, what is that reason? If I prove two triangles are congruent, and then the next step is the corresponding parts are congruent, what's that reason? CPCTC, you guys have got to get that. If two triangles are congruent and your next step is that parts of those two triangles are congruent, that is CPCTC. I guarantee you're going to see that. So let's say I'd already given you steps. Let's say I said number 2 is angle. So I've got 1 is to 6. I've got 4 is to 6. And I've got 1 is to 3. So now let's say I say 3 is congruent to angle 4. How do I know that? I basically went from 1 is to 6, 6 is to 4, so 1 is to 4. We are, but how do we get there first? No, look at the statement that you got. You got all of these parts, right? You got 1 equals 6 and 6 equals 4. So actually, let me do a step in between here so we can see if we can see it a little bit easier. What if I said 1 is congruent to 4?
Transitive.
It's transitive. Does everybody see that? So look at these two statements here. 1 equals 6 and 4 equals 6, right? So then 1 equals 4. Now what if I said it's like taking out the middleman. So if 1 equals 6 and 1 equals 3, so 6 equals 3, that's also what? Transitive. And then
Where did it say 6 equals 3?
it doesn't. That's what I just. So I did 1 equals 6, and oh no, it's not. Sorry, 6 equals 3. 6 equals 4. Yeah. I'm just doing 2 steps in one. 1 equals 6, yes. And 1 equals 4. So let me break it down even further. So 6 equals 4, right? That's transitive. If 1 equals 6 and 6 equals 4, then 1 equals 4. And if 1 equals 3 and 1 equals 4, then
4 equals 3.
and that's also transitive. So now I've got the 2 that were initially marked as congruent, which is the 1 and the 6. And now I've got the 3 and the 4 that are marked as congruent, okay? So you could have done that all in one step because it's a bunch of transitive steps in between. But as long as you can identify that's transitive. And then I already have that AB equals AE, so I can actually say at this point the triangle ABC is congruent to triangle AED. And what's my reason? So this is not here yet. Let's work backwards. That's not there yet. What would make this triangle congruent to this triangle based on the information I have? How many pairs of sides do you have? Good. 2 pairs of angles and the non-included side. So that's angle, angle, side. So then the next step would be that these 2 sides are congruent. AC is congruent to AD. And what do we say the reason is for that? CPCTC. So then I can say triangle ACD is isosceles.
Oh, how do you know it's CPCTC?
Because if I'm stating that two triangles are congruent, so then the next step is that those parts are congruent. That's CPCTC. I had to prove the triangles were congruent in order to get an additional pair of sides or angles to be congruent. But once you do that, once I say they're congruent, so then its corresponding parts are congruent, that's CPCTC. How do I know ACD is an isosceles triangle? What does isosceles mean? Two sides are congruent. In that little center triangle, are there two sides congruent? So what would be your reason there?
Side.
What makes something isosceles?
Two sides of the congruent.
What's that called?
Side and side.
If I drew this picture and I said, is that triangle isosceles? You would say yes. And how do you know that?
Side, side.
What would that be called?
Definition of isosceles.
Definition of isosceles. So if it takes you to know what isosceles means, right, to know what that statement is, then that's the definition of isosceles. So I would say this is a little bit harder than the one that's on your test. I don't think it's that difficult, but you obviously have to know your reasons. Like you have to know if the statement says triangle this is congruent to triangle this, then I'm looking for one of my 5 acronyms. If the statement then says after that two corresponding parts are congruent, what's my reason going to be? CPCTC. Okay? So look for your obvious things like reflexive sides. If they're using parallel lines like the last one, look for alternate interior angles, that kind of stuff. But I guarantee that if one step is that the triangles are congruent, obviously that reason would be one of the 5 acronyms. If the next step is that parts of that triangle are congruent, that's CPCTC. Don't make something that should be super easy hard because you're not familiar with it. So for review, you can take advantage of all the stuff that's on your module in Canvas. You've got your Quizlet that you can study. The chapter review is what we covered last week. These are the notes that we filled out last week. This was the homework that was done over the weekend, so you can take some time going back over that. This first Kahoot challenge is what we did in class, but you can definitely do the second one. And also the chapter 4 review, which is a PDF that I will post the answers to later today. So the answers will be posted. Please make sure you take advantage of this so that you're ready for your test.